Let's do a quick recap of exponents and exponent laws. So remember, what's an exponent? Well, if I have a number to an exponent, so this number up here, the 3, that's our exponent. Well, that just means how many times are we multiplying the base, is what we'd call it. So the 4 is the base. How many times we're multiplying that base by itself. So that would be the same as saying 4 times 4 times 4, since we have the exponent 3. And what happens oftentimes is we can have operations which involve maybe multiple parts of exponents, and we can simplify these operations using what we call the exponent laws. So let's go over them. First exponent law is going to deal with things when we're multiplying. So if we're ever multiplying the same base, so that's going to be important that the same number is in the bottom, what you can do is you can add the exponents. So 3 to the 2 plus 7, or 3 to the 9. Okay, so that's when we multiply exponents. What about if we divide exponent or numbers with exponents? So 4 to the 7 divided by 4 to the 3. Now let's do 4 to the 2. We're just switching things up. Well, in this case, whereas multiplication went to addition, division is going to go to subtraction. So 7 minus 2. And we did go through an investigation just showing like where do these laws come from. But for this, we'll just get straight into these laws. So 7 minus 2 gives you 4 to the 5. So division leads to subtraction. Multiplication leads to addition. So I'll just kind of circle those things. Remember, the addition and subtraction, that's in the exponent. The multiplication, the division, that's the actual what's happening with the numbers. All right, that's not the only things we can be doing with exponents. So what if I had, I'll use a variable this time, what if we had a to an exponent, but maybe that number or that particular part is to another exponent, so to the 5. If you have an exponent to another exponent, well, that's the same as just taking the one exponent and multiplying it by the other exponent. So 2 times 5, which is a to the 10. And you can take this idea and also use it with fractions. So if I had the fraction, 2 over 3 to the exponent 3, we can take that exponent and apply it to both parts of the fraction. So 2 cubed and 3 cubed. So the outside exponent can, in a sense, come into the part inside the brackets. You just have to be careful with what you do it. So multiply if there's already an exponent there. If it's a fraction, apply it to both the numbers in the fraction. Okay, what are some other things? So the last common thing that we look at with exponents is, well, what if we have a negative exponent? So maybe we have 7 to the negative 2. We want to convert that, simplify it, and oftentimes we don't like having negatives in our exponents. So that's just the same as to get rid of a negative exponent. Just take that number and flip it over a fraction. And now you can just say that's to the exponent 2 now instead. And then we could use what we just said. If you have an exponent outside a fraction, you can just apply that directly to the fraction like that. Or, similarly, if you have a fraction, let's do 3 over 5 to the exponent negative 4. I'm just randomly choosing numbers here. What you can do is you can flip the fraction, so 5 over 3, and that would be to the exponent 4 now. And again, you could also apply that exponent on the outside to the individual parts of the fraction. And there's a look at some common exponent laws that we've made use of.